warned me on the Slack when I.
Hey everyone, how's it going? Welcome to another IoT Live, and we are live. Tonight we've got, as always, Cliff Aegis there. Hey Cliff,
Hey
and
everyone.
then
Evening.
beside Cliff, then we've got Brian Kostanich. Brian, you are from Wilderness Labs. So did you briefly want to tell people who you are and why we've brought you on the show tonight?
Yeah, so I am a co-founder and CEO of a little company called Wilderness Labs. Some of you folks might actually know me from Xamarin. I helped build that. That was the last company I was at, and I created Xamarin University and ran the Docs team and created that as well. And now we're doing something a little new and different, but a little bit the same. We're at Xamarin we brought the .NET development platform and framework to mobile, and at Wilderness Labs we're bringing .NET to embedded IoT. So it's kind of like just a continuation of the trajectory, I guess.
Fantastic, I like it. And obviously, Cliff is sort of a link between everything you do there, because obviously you're Xamarin and embedded there.
Yeah.
So there's no wonder that
Yeah.
that you're able to follow along and see the route that
Yeah.
Brian took there.
Yeah, and it's all .NET on IoT as well, which is awesome. So it kind of brings it all together. It's kind of I mean, as we've often said, myself and Pete, Brian, mobile phones and that is the ultimate IoT device, isn't it? Because you carry it in your pocket. It's a computer in your pocket, a supercomputer by IoT terms, but it's got all the sensors, a screen, and a fast processor all in your pocket, and a big battery. And it connects.
That's right.
So it's a perfect IoT device. So to go from doing Xamarin to building what you do with the Wilderness Labs and the Meadow boards is really good.
Yeah, and if we didn't have the mobile revolution, we wouldn't have the potential for IoT, right? Because the mobile revolution brought us just like really incredible hardware. There's sensors and peripherals and displays and batteries. It's like they're commodity cheap, they're reliable, there's lots of options, they run on battery. And also the advances in chip design, especially around ARM, which is like, when we're talking about embedded IoT, we're talking about microcontrollers, right? Not app processors, but we're talking about like little tiny chips. And the advances that happened in chip technology during the mobile revolution is really what is powering embedded today, because that gave us like these beautiful 32-bit ARM microcontrollers that use 1,000th of the power of, say, like, a single board computer like Raspberry Pi, and yet have all the peripherals and have all the hardware. And, like all that came from the mobile revolution. So this is sort of like a natural progression.
Yeah, it's quite telling that the early mobile phones we had, like the original Google G1s and the early iOS Apple devices. I mean, we've got now system on a chip on a board that's more powerful than they were, and that was what everyone was sort of cooing over. Not even 10 years ago. It's quite impressive to see how that technology and the drive from everyone wanting a mobile phone in their pocket has driven the chip prices and design along over the last kind of decade. It's very impressive.
That's right. And there's an interesting thing to me is that I remember growing up, and I remember I heard Bill Gates talk about putting a computer on every desk in every home, right? And we have blown so far past that, right? We went from a computer on every desk in every home to like a supercomputer in every pocket on every human being. And now we're at this place where the next epic, the next stage of humankind's technological journey is putting a device in everything, everywhere, right? And that's sort of, that unlocks the interactive world, because that means not only now can we get information, there's kind of like two phases to the IoT rollout. The first part is like, okay, we put sensors everywhere and then we get data in, right? But then what's going to happen is that folks will put interactivity, and so they'll be able to have control and power to actually change things in the world around you. And that's going to usher in a night and day difference in how we interact with the world. Just like The example I like to give is that imagine navigating today without Google Maps. Like that's new. 15 years ago, 12 years ago, we didn't have Google Maps, right? And imagine how IoT, how that computing presence in everywhere in the world around you, how that can change our interactions. I mean, it will definitely usher in a cultural shift for sure.
Not sure Bill Gates is quite happy with the fact that we've blown past computer on every desk, and he hasn't got a finger in the pie of mobile. I miss my Windows Phone. I want it back. It's the best UI of them all, I think. So
I think he's doing okay.
He's doing all right for himself. He's doing all right for himself. We might have a big legal bill coming shortly, but hey.
That's right. I don't think he's worried about his next meal or anything.
Not until after the divorce, anyway.
Right.
So you mentioned you started out at Xamarin and helped with building Xamarin, and working with Miguel de Casa and the likes, building that up. So then you kind of stepped away. What made you go to build kind of Wilderness Labs and building IoT and porting .NET and the Mono runtime to put on a small board? Where did that spark come from?
It's interesting. This is something that I've been wanting to build for a long, long time. Ever since .NET was released, I thought, man, this is amazing, but how do I put this into physical things, right? And I played with, back in the day, there was this thing that Parallax was a company down in California. They made this thing called a basic stamp, and it allowed you to do their kind of basic language and run it on a microcontroller. And it was a game changer for me, and then I got into Arduino and stuff. And then the .NET Micro Framework came along, and I thought, this is great. This is fun, and the problem is that if you do .NET, if you did the .NET Micro Framework, you quickly came up short. The .NET Framework stopped at basically .NET 1.0. It didn't even make it to 1.1, let alone 2.0. And that was always like a real limiting factor to me. I was always sort of disappointed that like we couldn't go further with the .NET Micro Framework, and that we didn't have a real .NET solution for hardware, right? And and so we got acquired at Microsoft, and we got acquired in 2016. And that same year, I transitioned my team over and whatnot, got them set up, and then I actually formed Wilderness Labs with some friends in October of that year. So I didn't last a year at Microsoft. The big company thing and the politics and all that, I was just like, man, I got to get out of here. I got to go build. I'm a builder, like I really want to be able to move fast, break things, and move. My entire career, I've been, on the bleeding edge and moving technology forward. And, that's just it's hard to do that at a big company. And so we formed Wilderness Labs, and it was kind of interesting. The kernel of this started because it actually came out of .NET Micro Framework. And even at Xamarin, like, we had done a lot of work with the .NET Micro Framework and at Evolve, our developer conference. We had our Darwin room, and we had little rovers that you could drive around with your mobile device, with the Xamarin app, and they, it talked over Bluetooth, and it ran .NET Micro Framework, had a NetDuino on there and stuff, and that was fun. and I always wanted to do the hardware, and we've known for a long time, like, this is the next part of the revolution, right? We had mainframe computing, and that shrunk down. We had desktop computing, and then the web came along, and everything was a web app, and then the web turned into cloud, and then mobile hit, and those sort of paired together real nicely. But we always knew, like, this next thing was embedded, was physical computing, and I've always really been interested. And what happened was that a friend of mine, former CEO of Secret Labs, who created the NetDuino, they ran a breakaway. They had ran the most popular, most successful Kickstarter campaign of all time at this time. It was for an agent watch. It was a smartwatch, and that thing, that was through a series of mishaps and missteps. Basically, Secret Labs melted down, and the watch was never delivered. And he was saying, hey, was just catching up with him. I was just saying, hey, what's going on, Chris? And he's like, I think I'm going to have to sell Netuino. We need to we're going to dissolve Secret Labs. And I was really sad about that because Netuino was the leader for .NET Micro Framework boards at the time. And I was really sad I wasn't ready to see that go. And it sort of like just put a little nugget of thought into my head, and I started thinking about like, well, if we were to if what would I really want in this space for an embedded .NET solution? Like, what would that really look like? And it was clear that it wasn't Netuino. It was what we're building now, Meadow, which is like miles and miles ahead. But Netuino was like an interesting stepping stone, and so so I said, all right, well, we made an offer on Netuino. We got it for, basically a steal. And we used that to prototype, and we used that to as a playground to build a lot, to test out a lot of our ideas around, IoT. And that's how Meadow was born, because we always knew that we wanted to the .NET Micro Framework and its siblings, that are out there, were always dead ends, but we wanted real .NET. We wanted full .NET. We wanted the same experience as if you were building a Xamarin app or, a UWP app. We wanted generics, and we wanted to be able to grab NuGet packages that were out on the, out in the world. And we wanted async await. We wanted the difference between .NET 1.0 and where .NET is today is just, it's night and day. They're not even the same thing. It's like the difference between, I don't know. It's the difference between JavaScript and C#, that's the terrible analogy, but they're so wildly different. Right. And so we wanted a real full .NET experience. And that's what, we always knew that that's what we wanted to build. And we used Netuino to help us get there while we were working on this thing in stealth. And, we didn't tell anyone about this for years. So a lot of folks just thought I kind of disappeared or whatever. But in fact, we were just in stealth building this sort of next gen technology. And it's taken a long time.
Yeah. Yeah. So it's been interesting. I mean, I backed it on Kickstarter as soon as I heard about it. I think I was number 800 and something. And, I got a few boards, and I've played with them. So they're not quite there yet with being ready for using on in a production app. I've used them with clients on little fun projects, proof of concepts, that sort of stuff. So, I mean, where are we at the moment? I mean, beta 4 dropped, a month ago, was it? I think maybe a touch longer. I can't remember now.
It was we dropped beta 4 at the beginning of the year, and that gave us, I think that was our
that was still the Wi-Fi stack and things like this, wasn't it?
That was we already had Wi-Fi, but beta 3 gave us Wi-Fi, beta 4 gave us SSL and HTTP server and whatnot, and 10x performance. So the next thing that's coming out, and you're right, we've been at beta for a long time, is a really, really hard problem, by the way. Yeah. This was we never expected that. We thought, okay, maybe a year to get this thing to market, and 5 years later, we're just now we're actually finally getting close to V1.0 and being RTW. But yeah, so we've got this. Up next, we have a massive beta that is getting ready to drop. We're prepping it right now, and that adds some of the final features. Bluetooth is dropping in this one, and that's the last kind of major core feature. And there's a number of other things that are coming out. Visual Studio Code, VS Code support is a big one. And gosh, what else is on the? I actually have to look it up, because it's like a huge list of things.
Yeah.
And, where do we get that list? Is that on your website there somewhere? I can drop a link in the chat then.
For the upcoming beta.
Yep.
Yes, we haven't. It's up on our beta site, which I don't generally share, but I'll put it here.
No one's listening. It's fine. Just the world.
Yeah. So there's a pile of stuff that is happening in this next beta, and those release notes are, by the way, are not up to date, but gives you kind of an idea of some of the things. But yeah, we're getting close to V1.0. We expect later this summer that we'll get to, RTW, which would be our V1.0 release. We've got this release, and then after that, the next sort of, it's mostly stabilization.
Yeah.
But after that, there's a couple of things. Over-the-air updates is another key part of this, and then we've got some cloud stuff to build around that, and then we're 1.0, and we actually have customers today that are building production solutions. They're because it takes a while, it takes some time to prototype and work out the bugs, and so we've got some early customers that are deploying, and they'll be deploying later this year on our RTW release. So we have some folks that have made bets on us, and which is nice. It's good validation.
Yeah, I mean, I've used them with a couple of client projects as proof of concepts. They work brilliant, and the fact that I can write .NET code, which I'm happy with, and I know where I am. I mean, I'm quite happy sitting in Arduino C and Python as well, but to write .NET in Visual Studio and it runs on a little board sitting over there is just, it blows my mind every time I deploy and it works. A, because my code works for once, and B, because it's an IoT device running .NET. But yeah, I mean, over-the-air updates and Bluetooth are two things that I'm looking forward to seeing come to the platform. Bluetooth, because I'm if anyone's ever watched me give my talk about handy to hand, then full well that Bluetooth at the end of it I talk about putting a Wilderness Labs board in the back of Handy. So I'm looking forward to doing them, bringing it all to .NET. But yeah, and over-the-air updates just means that you can do what IoT is meant to be, which is battery-powered device sitting out on the edge, connecting via 3G, 4G, LoRaWAN, whatever, and you can push an update down to it. You can connect it up to Azure and digital twins and the other things. But I mean, we've got the Meadow F7 board at the moment. I mean, describe the board, because there are a few people in the chat that have not heard of this before. But I mean, describe the board. What is it that's so special about the Meadow that is different to maybe an Adafruit or an Arduino board that you guys are doing different?
Sure. Yeah. So, the first thing is this is really about the platform. The hardware's, we've really best in class hardware, but it's about the platform. So you've got the power and speed of embedded C with the ease of use of MicroPython, right? So it's best in breed. And the board itself is very, it's a very advanced board. It's meant for industrial and commercial, real IoT, embedded IoT, where it might be powered by a battery, needs to be able to be managed in the field. And there's two form factors. There's the developer board form factor, which you're familiar with, and this has got 32 megs of RAM. It's got 32 megs of flash, so there's lots of code space. There's lots of memory space. And it's got an onboard battery charging circuit, so you can, you can plug it into the battery in a USB, and it'll automatically charge your battery. And it's got, the main processor is the STM32F7, which is one of ST Micro's flagship microcontroller, and it's really an incredible microcontroller. It's got twice the power of the F4, which is basically what most of the world uses, and it uses half of the energy. So it's really just incredible. And then we have an ESP32 coprocessor on there, which provides us our Bluetooth and Wi-Fi. And so it's really, like I said, it's and it's got both an integrated chip antenna, so you don't have to worry about Wi-Fi chips or anything, but it also has an external antenna, a micro UFL connector, so you can hook up something like this and extend your range, and an API to switch between those two. So it's a really, really powerful board, and the architecture is really interesting because it enables us to do some interesting things. The main, we can do, the real-time processing on the main chip, but then we can offload like the network stuff to the coprocessor. And that's a model that we expect to exploit in the future as well, because for instance, if you have some ML to run, it'd be really nice to be able to listen to sensor inputs and drive hardware from the main chip and then run your ML model on the coprocessor, right? And just offload that. And because of the power management and whatnot, these, we haven't shipped these APIs yet, but you'll be able to turn off the coprocessor, put it to deep sleep, or turn off the main processor, put it into deep sleep, and get a wake up when you need to, and whatnot. And so we really are enabling those real industrial IoT scenarios. The other form factor that we have is we have the dev module, and then we have a production module. And the production module is basically headless. So there's no USB, there's no power regulator on board. And this also adds Ethernet and SD card functionality. So you can add a dual port. Yeah, you can add a dual port LAN switch to this. So you can do industrial LAN and power over Ethernet and whatnot. And so this isn't quite finalized yet. This is not available for sale, but it will be soon. And then in the future,
I'm thinking of applications for that already. So yeah, I'd be excited to see that one.
Yeah, it's almost done. We actually have it. We have the Ethernet and the SD card stuff validated. But what we're doing is that we're bringing this into a kind of a different form factor. We're gonna shrink it down and make it long, skinny, kind of more like the dev board, but much smaller. And then in the future we'll bring this to other chips as well. Like one of the things that we'd like to do is like an ESP32 only board. For let's say you're building let's say you're doing some ag tech and you want to do sprinkler management, water system, and soil management stuff. You might use your big board for your gateways and for your control, but like sprinkler heads might have you might want to use smaller, cheaper boards. So we'll do like an ESP32 only board that costs somewhere around $10, right? And you just put that anywhere, and of course it won't have the power or the flexibility of the other one, but it'll fit into sort of like different use cases, different scenarios.
And
I'm assuming that'd be
those running. Sorry, Pete, go on.
I was going to say, you might be asking the same question. I'm assuming that the ESP32 only board would be be embedded C programming in rather than full .NET.
No, full .NET.
Full .NET for ESP32. That's what you're saying.
Yeah, for sure. Yeah, it's totally possible. It's a different architecture. It's Extensa. So there's some work, and that's the porting work that we have to do. But it's totally possible. We've done some proof of concepts there, and yeah, it's totally possible. Just work.
So would that be we would get to use full .NET on an ESP32 as long as we bought your ESP32, or would you be somehow allowing other people to use it for their boards as well?
Yeah, there's two models. So you can either buy our board, which has the, it would have, so we would add external memory and external RAM and external flash to that because we'd want to be able to run, like full stuff, like if you want to put a web server on there, you need more memory. That's just, if you want to run TLS, you want to SSL, you need more memory, right? So we would add some additional componentry. But we would also, at some point we'll open source these, and you'll be able to just build these into your own circuits. And you can just license Meadow straight into your own circuit and run it that way. Now, I caution those who think that might be an easy task, because I will tell you, this is hard. This kind of like, let me tell you, building this is easy. So taking sensors, peripherals, and things and adding them to a module and getting them working, that's the easy part of hardware. But building the core compute module, this is insane. This is $75,000 to $150,000 of R&D, because this is an 8-layer board with controlled impedance, high speed signaling with, differential signals, and all the memory lines all have to be the same length. And there's RF tuning, and there's, FCC certification, all that stuff is like really hard and expensive. So you can build it into, you just put it into your own board. But I do caution that, it's way easier to spend $30 and buy a board than it is to spin one.
That makes a lot of sense.
I followed since the very beginning with Kickstarter, and I'm often on the website seeing what's new, what's coming, on the forum as well. I don't post as much on there. I'm not on the Slack channel on that, and just follow along. But it's interesting to see where it's developed. I mean, the fact you've got the whole community involvement building the drivers for all the different things like the displays and the sensors and things like this. The fact that the board and the pinout is pretty much the same as the Adafruit Feather, which means all those. I mean, that must have been a conscious decision to pick something that is so ubiquitous as the Feather system, where you can just put all the hats on top and plug away, and you suddenly got all those peripherals like motor controller boards and LED boards, etc. You just plug in and they're just going to work. Bless you, Pete.
Excuse me.
Yeah, no, that's right. When we were first doing this, when we were first designing the Meadow board, the Adafruit Feather was a brand new thing, right? And we were looking around and we were like, well, we don't want the Arduino form factor. Like, that was great in like 1992, but that's right. It's this big, and that was fine for Netuino. That was fine for the old days. And we were looking around, and we actually considered our own form factor. In fact, the initial designs were of our initial board designs looked like a feather board, and then we discovered the Feather board, and we're like, well, this is perfect. This is a standard, Adafruit. We love Adafruit. They do great work, and it's got and there was a lot of love and a lot of thought went into it. The idea of like having an onboard battery charger, for instance, and having standardized I/O. That was really that was definitely good, and we definitely took a look at that and said, this is the one. This is what we're going to use for sure.
So we've talked about the hardware, the form factor, and stuff. So tell us about the actual. I know because I'm seeing it, but hearing it from yourself, the stack of the software. We've got kind of .NET, but what's running underneath that? I mean, all the way down to the chip level. You've got like some mono and things. So just explain that, just for those that are watching.
Yeah, that's right. So it's actually kind of interesting. Microcontrollers are different than any other class of computing, right? We think about IoT, and IoT is sort of serviced by about 95% of all IoT is embedded, and that's microcontrollers. And then about 5% of IoT winds up being single board computer like Raspberry Pi and stuff. But microcontrollers are interesting because they are sort of like take the computing model that we're used to and it puts it on its head. So in a microcontroller, the OS is not the thing. The app is the thing, right? So if we think about like computing at other levels, if you think from single board computer on up, you think of like, okay, there's this big heavy OS, there's multi-users on that OS and multi-desktop, there's like multi-apps, and that's like the Linux Win32 Amiga, like that's the paradigm of modern computing. Microcontrollers are different. On a microcontroller, there's just enough OS to service a single app. And so what they run are micro RTOSs, micro real-time operating systems. You don't put Linux on a microcontroller. There's sort of flavors of Linux that can run, but they're not Linux. They're POSIX. They're POSIX compatible, which is what Linux and Unix sort of, agree that's the API of the underlying syscalls as opposed to like Win32, right? And so our stack at the base of it uses NUTX. And NUTX is a bulletproof micro RTOS that's been around for like 19, 20 years. The kernel is created by Greg Nutt. And the kernel is probably one of the finest pieces of software engineering on the planet. Userland is a little different because it's kind of hodgepodge community stuff. But that kernel is really powerful, and it's really lightweight, and it's very small. It's like 30K or something. So we run NUTX, which is pretty heavily modified. We've got some shim stuff on top of that. We've had to extend some of the POSIX features, and we've had to change some of the way memory works in there to work with the .NET runtime, because the .NET runtime has a very specific set of requirements around memory, et cetera, right? So on top of that, we have the mono runtime. And that is how we get our .NET support. We run Mono 5.9 or something, which actually, by the way, one of the big parts of this next release is that we'll have full .NET Standard 2.1 and Core 3.0 support. So we actually support that today, but we weren't shipping the Net Standard facade DLLs. So if you try to actually use those APIs, it would say, hey, where's Net Standard DLL? So that's something we're going to fix. But so that's how we get .NET. And that is, then that Mono uses the POSIX calls down into NutX to have its runtime. And then on top of that, we have built a massive set of hardware APIs to make hardware super, super simple. And it's really interesting. We sat down and we said, look, we're building this thing tabula rasa. This is from scratch. We have an opportunity here to fix a lot of the things, a lot of the cruft and hardware that has been in there since the 70s, right? Because the way serial port works, for instance, is probably the way that it works because in 1976 or 1967, some engineer did a POC of serial comms and said, okay, this is how it's going to work on this project. And then that became the standard, right? So there's a lot of stuff in hardware that was just like mind-bogglingly upside down. Let's pants on head. And so we sat down and like at every point when we wanted to expose an hardware API, we asked ourselves, this is how it works today. What's the right way to do this? And we have created this beautiful hardware abstraction called MeadowCore. And then also MeadowOS is the managed access to the OS underneath, which provides you, that provides the power and sleep APIs and device information and Ethernet and Wi-Fi and stuff. And then there's the hardware APIs. And then on top of that, so that's basically like, that's kind of the stack. But on top of that, we also have Meadow Foundation, which is this massive peripheral driver library. And if you click there on the peripheral, click on that, you'll see this has got, if you go and grab peripherals from Adafruit or SparkFun, whether they're an analog temp sensor, a BME 280, or a load cell, or an e-paper display, and you plug them in, we probably have an API for them. We've got just piles and piles and piles and piles of drivers that all look, smell, and sound the same. Like you can swap out one eye temperature sensor for another eye temperature sensor. Like it doesn't matter if it's a BME 280 or a digital, it doesn't matter if it's a digital sensor or it's an analog temp sensor. They just work the same, right? And so we have spent a lot of time and effort to make those really easy to use. And the idea here is that you can build hardware without thinking about the hardware plumbing. You don't have to write a driver. You don't have to worry about like low-level bit banging or I2C address, reading addresses or registers or whatever. Like, and all that stuff is just, we make it easy. So that's kind of the stack of a Meadow app. And now we're working on something called Meadow Cloud. And Meadow Cloud will enable you to, and this is kind of the final piece of the puzzle, is that Meadow Cloud will enable you to manage those devices out in the field. So as part of our security posture, security has been something that we've been thinking about from the ground up since the very beginning. So things that we're working on in that space are encrypted firmware with over-the-air updates and bootloaders and secure key storage and making sure that we're doing key rolling and that we keys are managed correctly and we're using SSL and HTTPS to talk to things and whatnot. And as part of this, you'll be able to use Meadow Cloud to push out new app updates to your device out in the cloud. So the idea there is it's a little bit like App Store. You upload your package and you hit the button, and Meadow Cloud will you sign it with your developer key. Meadow Cloud will then encrypt it and sign it with your corporate key, push it down to the device. The device will update itself, will swap out the underlying operating system, download the application package and put that into place, and also put in the coprocessor firmware as well. So it just takes care of it for you. Now, to be clear, that doesn't preclude using other services as well. You can still use Azure, AWS, or any other thing that you want, but that's for over-the-air updates. That's how that'll work, and that's kind of the last piece of the stack that we're working on.
Would that mean then it'd be similar to, I can't remember the name now, like a particle in that, where you have to go via their cloud to do the updates, the over-the-air updates? Because I only mention it because I had a client that we looked at Particle was a good few years ago. Their stuff was around, wasn't it? And we was looking at a project, but purely because it had to go by their servers, and I don't know why they wanted. They were stuck with no, we have to use Azure, and we can't go anywhere else. They wouldn't allow us to use that hardware. They're a bit of a weird bunch, this client, but that was one of the things that they had. So would that be the only way of getting over the air updates, or would you still be able to use the likes of Power of Azure and AWS to push updates?
So initially it'll go through our cloud, but I think what you can do is that you'll be able to push up to Azure or whatever, and that can push to our cloud and then go that way. So we'll offer at some point an integration there. Ultimately, as part of our security posture and our security module, our model, it will go through the cloud. But that also, we'll also provide on-premise cloud for folks that need, for folks in like operational theaters or fintech or government clients, et cetera, where they need on-prem private stuff, then we'll facilitate that as well. But the idea is to use that we'll make it easy to sort of like originate them from anywhere, but they will absolutely have to go through they'll go through that pipeline, at least initially.
Yeah, cool. There's some questions in the chat asking about the version of .NET that is supported. Are you going to, when with the .NET 6 and the move away from Mono, are you going to come across with that? What's that story looking like at the moment?
Yeah, so that's actually really interesting. That's a great question. And so today we support .NET Standard or .NET 4.72. With the next beta we expect, and then that's on, and also .NET Standard 1.6. With the next beta we expect to have .NET Standard 2.1 and .NET Core 3.1, which are, to be clear, are actually today supported in our runtime. We're just not shipping the DLLs. We're building them, but we're not shipping them. So we're going to fix that. And then we're going to skip .NET 5 because 5 doesn't have. So a little bit. So to understand what's happening here, a little bit of context is useful. So for years, there were two .NET runtimes. There was the .NET framework, which was all Win32 APIs underneath. And then there was Mono, which was POSIX, so it could run on Linux and everywhere else, right? And these two frameworks sort of lived side by side and out in the wild for a while. And that's Xamarin was on Mono and like UWP was on .NET. And what is happening is that internally at Microsoft, they've known for a long time that like the right thing to do is one.NET. And that, in fact, that was what they called it. That was the internal project for a long time. It was called one.NET. And what that does is, it's actually kind of a misnomer to say it's moving away from Mono. In fact, what's happening is that the .NET runtime and the Mono runtime, the parts from both of these cars are being pulled out and they're making a new car, right? Because the .NET runtime has never really had the exotic platform support. It was very Win32 and, Core abstracted that stuff, but all of the real work to run on those exotic platforms was in Mono. So what .NET 6 is doing is that's the final grand unification of those two runtimes. So they're taking the Mono POSIX stuff and they're taking the .NET runtime, the BCL and a lot of that stuff, and they're putting that together into one runtime that will be totally cross-platform. The interim, now that was supposed to be .NET 5, but I think that was, and the .NET team said, well, COVID hit and that pushed us behind. I think that was always way too optimistic. That was never going to ship in .NET 5, even if COVID hadn't hit. Like I'm going to go on record on that one.
I agree with that.
There's no way.
There's no way that was going to happen. And I'd be seeing what's still going on in the Xamarin world at the moment with .NET 6 and it being one kind of .NET. I'd be impressed if they make November. I'd be very impressed. I think it'll be kind of .NET 6, 3, 4, 5-ish. Yeah.
Yeah, well, you know what? Whatever's going on in Xamarin is Xamarin, right? But what we're going to do, so we're going to have the .NET Core 3 and Standard 2.1 support in this next release. We're skipping .NET 5 because .NET 5 won't run in these other places, right? It has unofficial support for like ARM 64. I don't know if it has anything for ARM 32 or other stuff. But all the work is happening in that, the .NET 6 runtime stuff. Now, most of that stuff will actually be done this summer, the runtime stuff. And so we're going to start our process to port to that. So we're rebasing right now. We're rebased on the latest Mono. So we're up to speed with Xamarin. The next thing we'll do is we'll rebase. We'll pull down the .NET 6 runtime, and then we'll be .NET 6 complete as well. And our hope, fingers crossed, is that we can hit .NET 6 compatibility the same time that, in November as .NET 6 ships. So we should be able to keep up to speed. And the reason for that is because that work is largely done. There's some things here and there they're fixing. There's like a lot of edge cases around LLVM and running on on non-x86 and AOT and things like that. And they're fixing that, but largely it's done. Now it's edge cases. So we're going to start porting to that. And then hopefully, like I said, by November, we'll be able to launch at the same time.
So you're not having a summer holiday? Fantastic. You're not having a summer holiday then, no?
What's a holiday? What's a holiday?
Yeah.
Let's start up.
Yeah.
I don't know.
Buy airplane tickets like you bought toilet roll is what I say. I should have worn a t-shirt, shouldn't I?
You should have done, yeah. So, how does sort of your board and full .NET look when you compare to something like the Nano framework? Have you seen much about Nano framework? Mm-hmm. And sort of obviously yours is a full ecosystem on top of the full .NET framework, so it's outstanding, obviously. But I just wondered whether or not you look at other projects like Nano framework and think there's a bits that we can take from that, or there's a bits that perhaps you collaborate. I've got no idea.
I love I love those guys. I love Jose Simoes and that team. They're really an incredible set of individuals and a great team. But there's not much in Nano Framework for us. Nano Framework is literally just a port. It's a rewrite of the .NET Micro Framework. And so it has all the limitations and sort of like, it's basically what they did is they took the .NET Micro Framework, fixed some of the deployment stuff, and then shoehorned the .NET IoT Core API onto the Micro Framework. And so for us, it's a dead end. Like that's 20-year-old technology, and that's not. I'm glad that it exists, and I really love those guys. But it's not. I don't think that that's a path forward for serious IoT development.
Yeah, makes sense.
So where do you see once you've gotten to RC and you've got the Meadow Cloud or whatever the name is, where do you see kind of moving next? What's the next 5 years looking like for Wilderness Labs? And
well, hopefully we'll take over the IoT world.
Yeah.
I mean, let's put it this way: when we're production ready, the idea here is that we will provide a platform in which it makes absolutely no sense to do like 90% of IoT projects won't need embedded C. When you have the speed and power of C via C#, and then here's something that's crazy. 70% of all security bugs are due to memory management errors, buffer overruns, and such. Those things don't even exist in .NET, right? You try to overrun an array, just try. I dare you. You can't, So if we can, I think that we are positioning ourselves in a place where we can be a majority, a majority player in embedded IoT. If you're I want folks to go out there and look at the platforms that are available, look at their choices, and say, well, you'd be hard pressed to convince me to do anything but Meadow for most IoT solutions, because I can build it faster. I can do it 10 times as fast as if I were doing embedded C, and it's much more secure and it's manageable, and they have hardware for me. Everything's crossed off, right? That's where we want to be. We want to be the choice, the go-to platform for embedded, and this is a place where the sky is the limit, because unlike mobile, there is no iOS, there's no Android out there. We are that. We are the platform from the base on up. So I think there's a huge opportunity here for us to really be able to provide and be the default platform for embedded. I mean, why would you use anything else, really?
Yeah, I mean, and also if you're a .NET developer, and there's plenty of them in the world, you basically can get into IoT without having to learn. Oh, okay, well, I did Python at college, and I think I remember how that works. Or use an Arduino C and think to myself, well, where's that library gone? Because I know that from C, it doesn't exist anymore. And that's for me, IoT at the moment is the struggle. And then I go and write a Xamarin app, and it's like I'm back in .NET land. I'm happy. Just even the hello world for a Meadow app is basically a command line. It's if Pete finds it, I think it's top left of the screen there. Pete, you got the hello worlds or hello Meadow. It is literally just a console app. And
yeah, that's right.
That's it. It's real nice and easy and simple. So Pete, sorry, did I jump on your question there?
No, that's fine. I've got all the questions. There's so many questions, and I know that you have as well, Cliff. A couple of different things. I was speaking to somebody at Microsoft who intimated that that C# devs aren't their target for IoT at all. And I think the reading between the lines there, they were thinking that anybody in the space just wants to use C. They don't want to use C#, and C# devs aren't IoT devs. And that was reading between the lines of that single comment of C# devs for IoT are not our focus. What's your answer to that? Obviously, this is.
I think they say that because they don't have a C# IoT play. I remember talking to Guthrie 12 years ago, and he was telling me that Windows Mobile was the future. And we were like, we're building Xamarin. I'm like, well, there's this thing called iOS. It seems to be pretty important, and Microsoft will say that until they have a C# IoT play, until they acquire Wilderness Labs or attempt to build it themselves.
I mean, I've been pushing that from the other side, from the Raspberry Pi side. So I've got a single line install script for .NET on a Raspberry Pi that people have been using. There's no sudo apt-get for a Raspberry Pi for .NET, and from that side, if you could capture the Raspberry Pi market of C# devs and show them that they can go and buy one of these Linux devices and get C# on it, you would have thought it would have been a no-brainer. But the fact they've not done that kind of speaks to where their focus is. I mean, certainly, they bought ThreadX, didn't they, for RTOS and stuff like that. So you can see that there's a focus there for that as well.
I mean, look, Microsoft has never been an innovator. They ever since maybe in 76 April 4th they were an innovator, but they missed out on internet. They were years behind on that. They missed out on mobile. They were years behind on that. And this isn't just Microsoft, right? All big companies, they don't really innovate. They buy innovation. They acquire innovation. They acquired Xamarin. And so they're not. That's just part of being a big company. Then that's and actually what's interesting is you mentioned you've heard that C developers, they just or IoT developers, they want to do C, and that's an interesting point, because one of the things that we've sort of been pleasantly surprised by is the number of folks on our platform that were embedded C developers. We never expected, truthfully, when we did this, we thought, okay, well, this is really about the 10 million. There's, some, depending on how you count, there's between 20 and 25 million developers in the world. And there's about 10 million .NET developers, right? So depending on how you count, almost half of the world knows .NET. And we thought, okay, that's our target. Our target are folks that do .NET, day in, day out. This is their bread and butter. And what we're finding is that we have piles of customers that actually are doing Meadow development because embedded C is such a nightmare. It's just an absolute wreck. It is a train, it hasn't changed since the 80s. And so we have a significant number of customers that have come to us that way. And that really, honestly, that blows my mind, because we never expected that. Engineers And especially, like there's a sector of the world that's kind of like not, don't want to change and kind of set in their ways and stuff. And we thought that would be selling into those developers. And we have been pleasantly surprised, because like I said, if you've got the power of C, but you can code 10 times as fast, why would you bother?
It's been able to bring in the other libraries like Newton.json and stuff like that. You can just bring in a NuGet that does the job for you. You haven't got to write that code to just to do like send JSON up to a web server from an 80-foot featherboard, for example. It's not 5 minutes work, whereas it's a couple of lines of .NET code that you can write in your sleep if you're in .NET land. It's I don't know. For me, that's a winner.
There's a counter right. Oh, go on.
And imagine here's an IoT scenario, and this is like the golden IoT scenario. Let's say you're building a logistics tracker that, something that looks like this, and it goes on the side of a cargo container and has maybe some holes, some sensors inside that monitors the humidity and temperature of your bananas on the other side, right? And maybe it's got GPS, and maybe it's got an e-paper display on there, and that has maybe a manifest or QR code or something. So imagine you go up to this thing as, comes into port, there's your manifest is lost. So you walk up to this thing, you scan the QR code, which connects to this device over Bluetooth, serves up a website of the manifest information as well as the conditions of the bananas in there and where they're going and any messages. Imagine like in Meadow, that scenario there is a piece of cake. That's something that you could prototype in a couple of weeks, and then you add some hardware time to do prototypes and stuff. And you're like, a few months, you could probably build that. Imagine trying to build that in embedded C. Like, okay, so let's go find a Bluetooth stack. Okay, let's try to figure it out how to get that to work and like how to new up that tree. We need to find a web server. Okay, so we got to get a C web server. We've got to make it work on whatever flavor of micro RTOS using whatever make files we have for this particular like flavor. And then like, oh, that doesn't work with this particular dependency. But it is. It just gets worse. It just gets worse from there. And next thing you know, it's a year later and you still don't have your project. And something interesting, IDC released a report about IoT last year. Almost 80% of all enterprises are tasked with building IoT today. Not over 90% of their projects are failing. And they fail, they never make it out of pilot phase. And that's why, because today, it is monumentally difficult and expensive and time consuming to build IoT. And we take all that and we just put it on its head. We flush it down the toilet and say, look, you want to build IoT? Use this. In a few weeks, you're going to have your solution. And, you can use your existing team members. You're not going to fight with all the stuff, all the stuff that you're fighting with today. There's no make file that you're going to have to fight with. You're not going to fight with plumbing code for I2C. You're not going to have to find like the version of whatever web server you want to work on your operating system that works with your other dependencies and doesn't and there's enough memory and there's enough flash to like put all your stuff on there and not worry about, oh my God, I put this here and I put that there. And now what do I do? How do I get SSL? Because that's another 800K. Oh my gosh, I can't connect securely. Like it really, this is embedded is such a primitive mess today. And we just turned it on its head and we said, screw it. It's time for a modern play here.
Well, I think even Microsoft are owning up to that as well, because they're pushing, you look at all the latest, the builds and all this sort of stuff, the Azure IoT team are pushing edge compute, Satya Nadella is saying edge compute, and it's said in every conference. And that's basically taking a very powerful, Dell PC, for example, and sticking it in a muddy field. And then your IoT devices connect to that edge compute device, which then has all the power to actually talk to the cloud.
Yeah.
I don't want that big edge compute because that's my single point of failure for my 30 or 40 sensors that are out in the field. I want to go from that sensors out in the field that's low powered, running on a battery, connect over 3G once a day and upload my data, disconnect, go to sleep. That's what I want to do. And that's what I think IoT needs to be. And even to do that, I've done proof of concept upon proof of concept with clients. And like you say, it never gets beyond that because they see the fact that it's taken 6, 8, 9 months to just put a proof of concept together, and they've put all this money in, and they've got this little board which doesn't look very fancy, and they're like, "Well, is that all we bought? We want more." So yeah, I'm looking forward to the revolution.
Where's the cost? I mean, obviously, great power, great responsibility, and all that. Where's the cost come with having full fat .NET on a little tiny device? Because people are going to say, well, look, I've got no control if I go with something like that. It's going to be bloatware all over my device. I'm going to have 3.5K left of my 32K because .NET Framework's taking all the rest of it. Well, what's the answer? What's your answer to people that might say that?
Yeah, this is a different board than the RPi 2040 or whatever. It's a different board. We've added, there's a couple things. One is that the .NET of today is not the .NET of yesterday, right? Like with Core and with AOT and a lot of the advancements and innovations that we did at Xamarin, like we turned .NET into a different runtime. Like now you can full AOT these things and you can go to the metal, right? That used to not be possible. .NET was run in a virtual machine and, like it was heavy and blah, blah, blah. We did that, and then with linking, we can, take a 40 megabyte application and strip out, we shake the tree as it's called. And most of that falls off and then you're left with 4 megabytes, right? So like we have, without Xamarin, this wouldn't be possible, really. Like, to be honest, like Meta would not be possible without the work that was done at Xamarin and now is being incorporated into the .NET overall. The other thing is that we have added enough horsepower to this thing that it can run sophisticated applications so that you can drop in SSL and you can drop in, system.text.json and you can do whatever NuGet packages, you can add a web server and you're not going to shoot yourself in the face. We've added the memory and the flash to make that happen. And what's interesting is that this same problem exists in other boards today. We have a customer who, they do Bluetooth lighting and like they try to add features and it's like editing a Nintendo game. It's like, well, the sprite, that little bit of memory is like taken up by this sprite, and like, well, so let's do this one. It's like, well, that one's got this sprite and that one's got, it's like so that challenge exists today. And our answer to that as well, .NET is not, it's not your grandfather's .NET, number one. And, the hardware that we have to run this is quality. It's best in class hardware where it has, there's very little you can't do with it.
So you've got 32K of flash, 32K of RAM, I think I saw on that previous page there. Do you get all of that? It's 32 meg rather. Do you get all of that left? Or is it like when you buy a mobile phone and half of it's gone?
No, you get most of that. There's more than that because the chip itself, the microcontroller itself has another 2 megabytes on board. And that's where the OS and the runtime run from. And so we don't even count that in our, so the rest is basically app stuff. There'll be a little bit of space that we'll reserve for OTA we'll have to have a special partition it'll be a couple megabytes or whatever that we can drop in files and do swap stuff. But for the most part, you get that, it's available to you again, because the app is the thing, the operating system and the runtime is not, that's not large. The app is the thing.
So you mentioned before as well that you've got two processors essentially. You've got the ESP32 CoPro on there. So when it comes to OTA, are we going to be updating both of those devices, or do we have a choice of which one we update, and how does that story look?
Yeah, so what will happen is that you'll build a new package, which will include the OS, and then and the OS is firmware for both coprocessor, for both main processor, coprocessor, and then your application and runtime, right? You'll hit the button, you'll upload that to the cloud, and we'll sign it. And then that will basically, what will happen is we'll send a message to the device and say, hey, you've got an update. And the device will say, okay. And it's a multi-step process. So first it'll pull down the NetX portion of it, and it'll swap out, the NetX and the runtime, and then it'll download the firmware for the, or depending on space, it may pull down the whole package at once, and then it'll move the ESP firmware into place. And we can do that today. Like even today, like when you flash a board, we move, we like handle all the flashing of the coprocessor and stuff for you, and then it'll move the application into place and reset, and you're off.
Awesome. Sorry, Cliff.
I was just going to say, we've got a question from TRP8472 in the chat. I'll read it out, Brian, for you. So for Wilderness Labs, for an enterprise, what could you deploy for a typical org, e.g. AC systems, AC systems, alarms, building monitoring, etc., run proof of concept that was, and then a mass rollout. So I suppose you're talking, what could you do with this board?
That's a great question, and it's funny when we first started Xamarin, and I would go out to we didn't have a developer advocacy org or anything. I was it, so I would go out and give talks, and I would talk about how mobile was the future, and you should be learning mobile or you're going to be missing out. And we get questions that'd be like, well, what should we build with mobile, and what can we build with mobile? And I would say, I've got ideas and I know what other people are building, but like the sky's the limit, and it's what got built in mobile, what got built in Xamarin over the years. Like absolutely, I would have never thought of most of those things. Now I can tell you about, I can talk to you. So I guess the short answer is that, look, you can build whatever your imagination brings you to build, and I'll never be able to think of all the things that you can build. But I can tell you, in looking at the IoT market overall, there's three pieces of it. There's consumer IoT, which is this like little fraction of the overall market, and consumer IoT is like, smart fridges and Nest and things like that. And that's what most people think of, but it turns out that's like less than 10% of the overall market. The majority of the market, and in fact, the simple majority is like industrial. And then there's a slice, like 30th percentage of commercial. And so commercial IoT are things like med tech, building tech, things in that smart buildings and stuff like that. But the majority of the work that's being built in projects that are being done in IoT are industrial IoT, and that's things like transportation, logistics, ag tech, industrial automation, etc. And that's where like people are building all kinds of really interesting things. And today, a lot of the stuff are sort of one way. I mentioned that like there's kind of two phases to the IoT revolution. The first one is like putting sensors everywhere and getting information. And the second phase will be actually being able to push data back and push instructions back and doing command and control. And so putting, and then giving those sensors and those devices, those real edge computing devices, their own autonomy and intelligence, machine learning and stuff, like that's kind of the progression that we'll see. But people are building, like on our platform, people today are building, there's a smart window controller. So the idea is that in every window in a house, there's a Meadow, and you can, they automatically open and close for passive heating and cooling. And when the rain comes in and hits the little rain sensor fingers on the outside of the windows automatically close. Or, you go up to your building control panel and you say, open these windows, or you control it from your phone, or GPS tracking is a huge one. So logistics stuff, a lot of people are building things around that. There's a lot of climate tracking. Actually, one of the most common things that people are building today on Meadow. We just did this developer survey, and we haven't gone fully through it yet, but I was looking at projects, and like a lot of people are building climate tracking, battery powered sensors. I've got my own personal projects. I'm building a smart beehive monitor that
See that?
monitors the weight of the beehive. I know when it's ready to harvest for honey, and it monitors the activity inside the bee hive and temperature. So I know if the bees are healthy, and also temperature outside. And so, like I can get alerts, hey, it's time to harvest honey, or, oh my God, killer hornets are our killer Asian hornets are here, like go out and fight them off. And other things we've built this thing called Klima, and Klima is a little board that hooks up to a weather sensor array like this, and has also temperature and humidity and pressure sensor on board. A BME 280 runs. You can plug it in via solar, and let me see if I can find
your favorite
nice.
Yeah, my favorite. Yeah, humidity.
Right, humidity. You attach this to your solar, your climate sensors, and you plug it into solar, and it's a battery powered weather sensor. And like, this is something I just learned the other day that the city of Tacoma, their utilities district, uses our platform to measure solar intensity so that they can do energy trading and energy forecasting. So people are building things. They're building all kinds of things, and I will, like, the sky's the limit, and I have no idea what folks are going to build in the future. And they're gonna like, that was one of the great things about running Xamarin is that every day I got to see like some new crazy thing that people had built, and I'm like, man, I would have never thought about that.
Talking of that, I mean, stepping sideways there slightly, you look at something like the ESP32 space, and there is a board for something out there to do anything you like that's got bits attached to it, whether it's OLEDs or extra sensors or GSM modules. And is this something you think that Wilderness Labs are likely to explore? Is maybe snap-ons for that, or specific boards?
Yeah, for sure. In fact, some of the things that you mentioned, like, we'll have a board that has LTE or cellular built in, right? That's just something that we'll do. And at some point, we'll probably spin a LoRaWAN board, because that's a common thing. And we want to make that easy for folks. And we'll do reference boards as well. Like I showed you, Klima is a reference board, and this is something that we'll sell on our store, and has a battery, has solar input and stuff, and we'll sell that for a reasonable price on the store, and you'll be able to buy that as a reference thing. But the other thing here is that actually it turns out spinning your own board is super easy, and in fact I do a live stream on Twitch every Wednesday, and I would say about a third of the time I'm spinning a custom board, and I can show you just how easy it is to do. It's Twitch/Wilderness Labs, and we've done many streams where I've, like, start to finish, I've done a board, I've spun a board. And so that actually, I think a lot of those boards that you see that have like this and that are specialized are like kind of great for the maker space. But for us, for professional developers, like, it's one of the things that we need to sort of get skilled at is like spinning custom PCBs. And it turns out it's so damn easy. It is so easy, and at first I was sort of intimidated by it, but like with our documentation, you can go look at our docs and it shows you a schematic for a particular sensor or something, or you go to SparkFun and you've got the sensor that you've prototyped with, you had it plugged in, maybe you had a BME 280 or something, and it was, it's plugged into a board like this. And then if you want to spin that into a custom board, you just go look at the schematic and drop those components into a thing, and it's like so easy. It's honestly, if you can code C, you can do that kind of hardware design.
Yeah, I mean, something like KiCad or something like this, you pop it in there, post the Gerber files after OSPark. I mean, Pete, you did it with a Pico producer, you're using actually to show off this stream. It's it is, it's a learning curve as all things, but it's a fun learning curve, and you get a bit of a ball back. I think only the bit that has you nervous is why you wait for the board to be produced and post out. So did I do that trace and the via? So I hope so. But so I'm sure you had that when you was having the wilderness boards made off in China and sent back and everything else. It was there must have been some nervous moments when you pushing by 50,000.
And to be clear, that's just part of the process. It's just part of the process. It's just like with mobile apps. You might push something out to the app store, and then you're like, oh, I got to do this, and then it's iterative. And that's why we get paid. That's why we get paid the big bucks, right?
Yeah.
That's where we come in. That's where our value as developers, as C# developers, if we can spin, simple hardware, then you'll be super, super valuable. And that's one of the reasons we have spent so much effort on education, on this, because just like at Xamarin, it was like a new platform for folks. Even if you knew C#, you still needed to know mobile, right? And with this, okay, so C#, you still need to learn some hardware stuff. And we are, we like really do everything we can to make that easy. And it turns out that it is pretty damn easy. I mean, and literally, like on my stream, I've spun probably 6 considerable boards on there. And like, I'll break it up. One stream, it'll take me 2 hours, and I'll spin the schematic for something like APREM or Klima. And then the next stream, we'll do the PCB layout. And honestly, it's a breeze. It's really not. It's not. Don't be intimidated by it. Hooking up like sensors and stuff to boards, that's not the hard part of hardware.
No, it's not. It's worrying about how long it's going to last on the battery and all that sort of stuff. It's sitting doing a bit of maths, which is not hard either. Just going back to the questions in the stream, in the chat, Dave R4444. So excuse me, I missed this earlier. Is the Meadow and associated firmware, SDK, etc., considered production ready, or still beta proof of concept consideration at this time? So where do you see it, Brian, like now versus where you want it to be in a year's time?
So it's not production ready yet. We're still in beta. We expect to hit production sometime, this summer, late summer. We've got a big beta coming out, dropping in the next few weeks, which will add kind of some of the final features. But we're definitely ready from a standpoint of, if you have a project that you want to start building on, it's going to take you 3 to 6 months to get that into prototype anyway. So we are ready to, we're ready to start projects on. And it's a very productive environment today. Honestly, it's, like we build and deploy way faster than Arduino for, it's like one metric, but it's very productive, and there's a lot you can do today. And there's very little that you can't do, honestly.
Just another question from TRP8472. Is there a framework to follow? RE guidance is what he says. I think he's basically saying, where do I go to sort of watch a bit more of this and learn some more? You've obviously got the Wilderness Labs website, but where else is there to jump in?
So I would say the first place to go is developer.wildernesslabs.co, and that's our developer, that's our docs home. And the next thing to do is buy a hack kit. So go to store.wildernesslabs.co and get a hack kit, because you're not going to find anything. You're not going to find a better value for like a bunch of components and a bunch of stuff that we've curated to get you running out of the box. So that's a dev kit, and that's just a board. But if you get a hack kit, it has a whole bunch of stuff. There you go. It has a pile of things. And the other thing to do is, if you go back to our dev site real quick, Pete, and then scroll down to, so go to developer.wildernesslabs.co, and then scroll down to more projects. So there's more projects at hackster.io. So there are, there you go, view more projects. So there are a pile of projects that you can build with a hack kit for using Meadow. And I'm not sure why it's weird that it's showing a bunch of Arduino stuff there, but there's just a pile of great projects, and that can get you, that's like a great place to get inspiration. And you can also find on our hack kit page itself, and I'll link it here. There's a list of project samples that you can go build with a hack kit, and that again, like super inspirational. Start there and just start building. There's all the schematics, all the code. and you'll be surprised at like what you can build out of the box and how quickly you can get up and running.
We've also got the I mentioned it earlier, but also Yoshimoshi Garage is mentioned as well. We've got the Slack channel, which is quite a good place to go and ask you questions if you get stuck. I've asked a few in there and gotten answers from you actually, Brian, in the past. So thanks for that.
Our Slack is very active for sure.
Yeah, it's a great place to go and drop a question if you get stuck, or just ask around. So I'm thinking of building this. What do you think? Will it work? The answer will be yes, and this is how to do it. But yeah, it's a very active Slack group. If you've got some questions on that. But I personally, I've been a supporter since the beginning. I think it's awesome. I agree with you, Brian. I think .NET and IoT coming together is the future for me anyway. And I think starting out by getting a couple of boards and playing and tinkering, and obviously watching me and Pete every week. As well is good. But yeah, I think I can't wait for Bluetooth. There's a lot of projects I've got that are waiting for Bluetooth, and hopefully that will drop soon. Not just handy, but I've got some client projects that are just hanging for Bluetooth, and I'm putting them off using the SP32 because I don't really want to write it in embedded C. It'll be a pain. It will be painful. I mean, I've got no hair for a reason. It's been pain, but I'm looking forward to seeing where this goes. I'm looking forward to being able to use it, with being able to say, oh, it's not a beta product, because clients are looking and say, oh, Wilderness Labs, it still says beta. It's like, well, it's not. The software stack is, but the hardware is there. It's done. If we buy the board now, it's still going to be the same board in a year's time. That bit's done. They're just building the software stack out. So, it'd be nice to take that label away and then prove to clients that actually this is a board you can think and use, and we don't need to go and get an ESP32 and the likes.
We're excited for that too. It's been a long road.
It has. It's been fun to watch though. So, we're 15 minutes over time, Pete, but I'm not sure if you got any more questions or is there any more questions in the chat.
That's what I was about to say. I don't know if you've missed anything in the chat there.
Richard Harding says, Laura Wayne, yes, please. I'd agree with that. That's pretty darn awesome, that stuff.
But do you know the .NET IoT SDKs and the device binding SDKs? Do they fit with this board? Or is there a gap there somewhere? No.
They're kind of Windows APIs, and they're like a lot of old style stuff. Our APIs are like a lot simplified and a lot cleaner and a lot more powerful. So you could port pretty easily, but they're not. We don't. I'd rather see Meadow APIs get into .NET than vice versa. Because it's you can play with them side by side and form your own conclusions.
What I like about the Meadow API is the fact that it's a standard design. So the way you've formatted it, there's a lot of love that's gone into the API design, and you can see it when you look at them. Is the fact that it's a standard way of doing things. So if you pick up one of the LED drivers, for example, for one of the screens, they're all pretty much the same, and there's just an extra couple of bits for that one because that's got this extra functionality the others don't have, and I love that because I think you mentioned earlier actually you can literally just unplug the one that's blown up and plug a different one in and change out the statements and it will work because the underlying kind of framework is pretty much the same, and it's quite interesting. It's unlike the device bindings, which are pretty high level. You've gone quite low level with it, which is nice. Which Pete's showing there. There's quite a few LED drivers I picked just because I'm doing a project with LEDs at the moment. So.
Yeah, we spent a lot of time making those. We're in this next beta. There's going to be a great big upgrade to Meadow Foundation. One of the things that we're launching is that no longer, like if you get a temperature reading, no longer will you get a float. Is that Fahrenheit? Is that Celsius? You're going to get a temperature object back, and then you can do .Celsius or .Fahrenheit. So we're eliminating unit errors, translation errors, conversion errors. And, we put a lot, you're right. We put a lot of love into that, and we really, Meadow Foundation takes a lot of community input, and we do a lot of, we bring in a lot of help, but we make sure that we curate, and the one sensor works the same as another sensor. One display works the same as another display. So we don't, our mission is to make hardware development as fast and easy as mobile or web development, and that's a lofty goal, but we're working on it hard.
It's good. The work, the work that's gone into it is impressive, not just by the team, but the community as well. And it's exciting times, I think, for IoT. I mean, me and Peter and everyone in the chat know, we've all worked with IoT for years, and see the pain that we've gone through and the hair we used to have, but no longer have. And now to start seeing it coming around to, you can write .NET, it will work anywhere from, your little device, battery powered in the field, all the way up to, the full cloud, and everything in between, your mobile device and that. So yeah, awesome. Is there anything else you want to say? Any kind of final comments from you, Brian, before we sign off the evening?
Thanks for having me. This was fun. This was a blast, and it's it's nice to get to talk about this, and it's nice to be at a stage in where we're kind of like we've got actually a productive platform, and it's fun, and it's really, honestly, it's delightful to develop on these days. I remember we were talking about it today in our we had an all hands this morning. We were talking about like our early prototypes, and they were this big. And they had they had all kinds of wires and modules coming off and stuff. And it took 20 minutes to deploy Hello World. And it was like, this is, we've come so far, and we're now, we've built something that I'm really, really proud of. I gotta say, this is way harder than what we did at Xamarin, but because of that, it's also a lot more fulfilling. We are really proud of this, and we put a lot of love into it, and it's really nice to finally be able to get it out to folks. And I'm excited about this next beta.
Yeah. You should be proud. It's an awesome system. The fact that you can just deploy from Visual Studio and it just works is fantastic. And thank you to yourself and all the team that put all the hard work into it. It's certainly going to hopefully make my job a lot easier as a developer in the future, pushing to IoT. Just finally for everyone, if people want to reach out to you and chat, ask you a question in the future, how would they go about getting hold of you?
Yeah, probably the easiest place, a place where I spend the most time answering questions and stuff, is our Slack channel. So if you go to wildernesslabs.co and you scroll down to the bottom, there is a Slack icon, and that will take you to getting on Slack. You can also find me on Twitter at Brian Kostanich. I don't spend a lot of time on social media these days, but yeah, and you can find us in Wilderness Labs on Twitter. But yeah, for sure, Slack is the best way to, that's like, honestly, you drop in there and you'll dig it. It's a good community too. It's a good set of folks.
Yeah. Cool.
Excellent. I really appreciate that, Brian. Thank you.
Thank you for coming along.
All right, gentlemen. Thank you for having me.
Thanks everybody else for coming and joining in the chat there. That was fantastic, and I hope you all enjoyed that. We'll be back next Tuesday. Actually, next Tuesday we've got Paul DiCarlo from Microsoft coming along to kick off what will be then on the Thursday following that a series of NVIDIA Jetson workshops that actually Cliff's going to work through. So 9 p.m. BST same time next Tuesday we'll have Paul DiCarlo. He's going to explain sort of what this is all about. And then, the following Thursday from around 2 p.m. BST, we'll do. We'll watch Cliff as he gets everything all set up over the next few weeks. It's going to be interesting to see. So do just keep your eye on our Twitter channel, and you'll see the bits and bobs coming out about what we're doing with that. But thanks once again to Brian, and we'll see you all next week. See you later.
Thanks, everyone. Good night.
Ta-da.
Adios.